You're gonna be late. You're gonna make us late.
Okay, so your assignment tonight is a multiple choice test. Okay. Thank you. All right. Settle down, please. Okay, you will read the question with me. You will read the question with me. Shh. It says, Ms. Arias, concentrate, por favor. Clark is not here.
Oh no, I think she's getting really. She got really sick.
Oh, okay. Pobrecita. Shh. It says, let f of x be a function defined by f dash of x. So they're giving you the derivative equals sine of x cubed in the interval 0 to 2. Okay? We're working backwards. Okay? The question says, read it with me. The question says, at what value of x does f attain its maximum value in the interval 0 to 2? So what are they asking for? Absolute max. And they want absolute max of f. So we consider the critical points and endpoints. Everybody okay there? Now remember, this is an MCQ. They're asking that question in an MCQ. Observe this. So what are the endpoints? Obviously 0 and 2. Now I'm letting you know, I do not know if I said this. Even though I know calculus very, very well, I'm letting you know, a good teacher, because some of you may be thinking, I'm thinking of becoming a teacher. I'm letting you know, I know how to do every single problem. But when I come to class, I come prepared, as in I've worked out every problem. So I can share things with you, as opposed to just winging it. I'm just saying, if anybody's interested in becoming a teacher, don't be a lazy teacher. Anyway, I'm letting you know if you have to graph sine of x cubed. Remember f dash, we're going to graph, critical point. Here's what the graph looks like. Okay. Right. I'm letting you know that's what that graph looks like. I graphed it on Desmos this morning to see what's going on with this graph. Okay. Look at me. So am I interested in monkey or donkey? Monkey only, because we need max. So say x equals monkey. That's your critical point. Last step, we will evaluate the function. Okay, now it got tricky. Do we know the function? Observe that. We don't know the function, correct? But I'm going to, and then another thing. Usually for these questions, I'm going to say something, think about it. Usually, don't they give us like a starting value? How many of you understand what I'm trying to say? Don't they give us a starting value and then we use net change, correct? Now, you're learning something new. Boss, pay attention. I don't need a starting value. So, the guys, f of 0, I'm going to make up a number. So, you're learning something new. Just make up, invent f of 0. It doesn't matter, really. Give me any value for f of 0. Just make up a number. 100. Okay, 100 is good. No, literally. It does not matter. You can choose negative 10. It'll still work. Now, is f of 0 going to be 100? For f of 2, can I use the net change corollary? Which is 100 plus integral 2 to 2. Sorry, what am I saying? 0 to 2. F dash. And we know f dash, remember. We know f dash. And then finally, f of monkey. Similarly. See? It doesn't matter. Don't understand saying, oh, I see what's going on. I don't care what that starting value is. For the advanced kids who say, like, I see what's going on. Am I not interested in actually the areas? I don't care what that starting value is. You can put 0. You can say the starting value is 0 and just evaluate the 3 integrals and write down the answer. It'll work itself out. But I wanted to share that concept with you. I don't care about that starting value. Okay, let's move on, please. All right, read it with me. Read it with me. If you're looking down, you're going to be behind the class. Right on 91. It says, a particle moves along the x-axis so that its velocity is given by, at t equals 0, the particle's position is at x equals 1. So what am I writing? X of 0 equals 1, or s of 0 equals 1. Okay, next, letters don't matter. What is the total distance traveled by the particle from 0 to 4? Write something down in your piece of paper. The question says, what's the total distance from 0 to 4? Write something down. Now, I'm sorry. So, Ms. Carrasco, so this is like the conversation we were having. Guys, that requires you to know a relationship. If you know it, you get the points. You don't know it, you just lost points. Mr. Jin, what am I writing?
Absolute value, v of t dt. What is
Integral, right?
Yeah.
You can't say dt without the integral sign. So that's 0 to 4. Absolute value of v of t dt. Everybody okay there? Now, for those of you who have forgotten, this is in the mustache key. It's that number to the left of, who has a calculator handy? I hope everybody knows what key I'm talking about. It's on the right, it's one to the left. Everybody okay there? Now what's this? What's this? What's going on with that x of 0 equals 1? It's not relevant. It was a trick question. Because what? Isn't that relevant? I'm going to speak slowly. Only if the question says, what is the position at 4 or something? Then you're using net change corollary. That was a trick question. They're saying who has good concepts. You just had to do this and you're good to go. This is not relevant at all to the problem. They were testing skills. Okay, let's move on. Okay, just use your calculator key. We're done. Okay, we've done a lot of questions like this. In your notebook, just copy this and phrase down. I want to teach you. This is from IM 3, pre-calc. Copy that phrase down. Mr. Baker and Miss Arias and Miss Sanchez, can you tell Miss, what's her name, Clark, that a video of the lecture is going to be sent to watch the lecture? She'll learn something before she attempts tonight's homework, if she's feeling well enough to do it. Okay, the lecture will be sent. Okay, then copy down this piece of information, please. Now, let's start with the assumption you have no idea what's going on. If you were to make a guess, like just an educated guess. I have no idea what's going on, especially the highlighted stuff. What do you think is true about G and F? They are inverse functions. Okay, that thing, if you copy that down, make a note to yourself. That means it's pre-calculus IM 3. That means F and G are inverses. That is their way of saying that, but not in a calculus way of clearly saying F and G are inverses. But that's a kind of weird concept in IM 3 and pre-calculus, that if F of G and G of F are the same, then they're actually inverse functions. Okay, now it's an easy problem. So we're going to do the way we always do for inverse functions. Okay, I'm going to find the derivative first. We're going to find the derivative first. So it says G dash of A. So what should I find first? I need G dash of A. So what should I find first? G dash of X. Good skills. Who remembers I can replace G with? How we always do. I should replace G with? Thank you. F inverse. Because we just said G and F are inverse functions. Dash of X. What's the formula? 1 over F dash of X. You need to slow down. This is a problem that requires working. Okay, the kids who tend to get 3s cannot work this problem only because they skip steps. Okay, what's this? They say G dash of 8. So, for the 100 billion time. So, is X 8? No. X is 8 on the inverse function. Therefore, Y equals 8 on the original function. Therefore, look at the information given. So, what's the X value then? 3. Can you see? Y equals 8. Therefore, X should be 3 on the original. So X is 3. Can you plug in 3 there? Oh, what's F dash of 3? 9. Okay, we're not done. So can we eliminate this choice, this choice? So we know that guy and that guy alone. And then they say, what's the point of the graph? Oh, on the inverse, we're talking on the inverse. Isn't the X value 8? So what should the Y value be? It's staring at you. 3. Because X and Y will flip. So the answer was E. Okay, they say, what should G of 8 be? Okay, G of 8 should be flipped. But unfortunately, it requires working in like keeping everything straight together. Not in a rush. You're not in a rush to do that problem. We will not do the entire problem. We don't have time to do this. Just copy down this piece of information. Again, just this. The question and this piece. So they say h of x, otherwise I give you information in a table. Don't be alarmed, it's a very easy problem. They say h of x equals parentheses 2f plus 3 times 1 plus g. I just removed of x. Okay? And the question says find h dash of 1. That's what the question says. We do this 100 billion times. So what should I find first? Thank you. Those are good skills. Look down. Therefore, I should use. Thank you. Product rule. Not complicated. So 2f plus 3 times g dash plus 1 plus g times 2f dash. And then what do I just do last step? Plug in the 1, show the word. So h dash of 1 equals 2 f of 1 plus 3 times g dash of 1, slow and steady, plus parentheses 1 plus g of 1 times f dash of 1. Are all the values given on the table? Can you plug it in carefully? Observe the parentheses, observe the dots, so you don't make PEMDAS mistakes. Ms. Carrasco, here's another way you can make a mistake because you're not attentive. Okay, I need to do this first, then multiply that. Just small things matter. Okay, small things matter. Let's move on.
You're right.
Okay,
That's a good one.
copy down 88, please. In case you're not aware, I'm working on the harder problems, not wasting time on simple problems to waste last time. It says the rate at which water is sprayed on a field of vegetables is given by R of t equals 2, radical 1 plus 5t cubed. Write it down. Where t is in minutes and R is measured in gallons per minute. No, it's not a trick question. That's all they want. Read the question and write an expression down. Like, this is what I need. Then you'll grab a calculator for homework. It says, during the time interval 0 to 4, what's the average rate of water flow in gallons per minute? Do not look at your partner, just write something down. Miss Arias. Exactly. Now, if a kid misinterpret problem this way, why are they getting confused? What would the question really say, and you would use that concept? Average rate of change. It matters. Words matter. It does not say average rate of change. So you're using MSEC. It just says average rate of the water. So 1 over B minus A, as Ms. Arias correctly said. That's it. It's a gimme problem. Grab your calculator and you're done. Okay, next one. Okay, that was easy. We're not wasting time. Okay, we will go over this. Copy down the table if you want to. Boyd, you're cute. Why are you putting your head here? You can just go to the back and put your head. You can be comfortable.
No, I'm not paying attention.
Okay, then put your pencils down. We need to work the choices. I have to be honest. There are things I can tell you to think about, but I can't show you how to do every single problem like this. You have to do some independent thinking. So my strategies for this, I hope you're paying attention, are these. Think of different kinds of graphs. Like, is that always going to be true? So they give us a graph, but these are specific values on the graph. Another small thing, that's f of x. That's not f dash, that's not f double dash. That's just a regular function. Alright? So part 1. Think of counter examples. I have nothing profound to say. Like, no, that need not be true. In general, think of like, why need not be true? When it says, which of the following must be true? The minimum value of the function is 12. True or false? So, can you have a graph that's for which that's not true? With passing through those points. So, true or false? It's not a trick question. Louder? True. You know that if you have a function like that, the minimum value must be 12. Why cannot the graph go like this, Mr. Jin? 5, 12. Okay, it's like this. 5, 12. and 6, 16. Okay, this is 6, 16. This is 5, 12. 6, 16. There's nothing given. These are only specific points of the graph. You have to be imaginative. I have nothing like really profound to tell you. I can't show you how to do every single problem. Like, can you show some imagination? Okay, so that's false. Okay, 2. There exists a value C between the interval 3 to 7. Okay, that's the entire thing. Such that f dash equal to 0. Think about the graph and say, what does f dash equal to 0 mean? What's going on in the graph? What would be true if f dash equals 0? I'm asking a simple concept. What would be true if f dash equals 0? Louder? The slope is 0. If the slope is 0, what might be true on the graph? It should probably be a min or a max. You have a horizontal tangent. Okay? So have a look at the graph and ask yourself, must that be true? Okay, I'm going to answer the question. Tell me why. The answer is true. That is true. But why? I'll give you a hint. We went over this yesterday. Mr. Fong.
The slopes go from negative to positive.
How do you know the slopes go from negative to positive?
Because the y value decreases.
Ah! He's alive. He's alive. He's alive. Can you see? The graph is initially decreasing. Okay. Now to be clear to Mr. Jin, not necessarily. It could be decreasing, but overall, it's kind of decreasing here and then starting to increase. Must you have a horizontal tangent somewhere along the line? Yes, go on. Sorry? Yeah, you're right. You're right. Oh my God, I love you, Sanchez. She says, can I use MVT with it? You're right. Have a look. Can we use MVT on these guys? She's alive. She knows what MVT stands for. I'm very impressed, Sanchez. Isn't MSEC going to be 0? Okay. And it says differential, so there are no sharp corners. Okay. She says, can I use MVT? Yeah, true. Absolutely. So we did it 2 ways in the other class. We did MVT, and then we said, wait a second, the graph is falling and rising. I must have horizontal tangent somewhere along the line. Okay, 3, true or false. Guys, I have nothing profound to tell you. Like, you need to be imaginative, like what is going on in the graph. Must that always be true? It says, f dash of x is greater than 0 between 5 and 7. Must that always be true? Mr. Ton is correctly nodding no. Because if you understood my lecture, what I told Mr. Jin, between 5 and 7, it's going from 12 to 16 to 20, but there's nothing preventing him from going like that. So that need not be true. Again, you're really thinking of counter examples. What might be a graph that does not satisfy these conditions? Is that clear? Let's move on. Oh, if you will sketch this figure, please. I'm being honest with you. I don't want to say I did a bad job, but this is actually a BC problem. But I've given you advance notice, in more recent years, some of the BC questions have started coming to the AB exam. So during the school year, we did not discuss a single problem like that. And I'm confessing to a flaw as a teacher. I should have probably done a better job to going and maybe at least 1 or 2 problems like this. But don't get me wrong, I'll show you how to do it, you'll say, oh, that's not too bad. So if you just sketch this figure, please, sketch this figure. And then I'll scroll up and they say, looks like the function that is modeling a loudspeaker, okay? It's a loudspeaker, on the axis it looks like this. And the actual function is x squared over 10, right? It's perfectly symmetric, it's negative x squared over 10. Put your pencils down, now I'm going to teach you the concept, okay? You don't need to look at the board. Sorry, you don't need to write anything yet. The question says, for this loudspeaker, please pay attention, the cross sections perpendicular to the x-axis are squares, find the volume. That's a regular problem. But the only reason you're alarmed is, what is that weird figure? What's going on there? Okay. If you understand basic principles, you'll be fine. Okay, let's start writing. So V equals, it's a cross-section problem and they're squares. Is there anything I write outside? Okay, look at that figure. Lower limit, upper limit, and then is it dimension square? Everybody okay there? Dimension square, dx. Okay, now watch. I'm going to guide you. I'm confessing we have never done a problem like this. Usually, look at me. Usually don't we do like F and G or something like that? But relax. What's that dimension? That's correct. I'll make it easy. Is that y? Is that y? Everybody okay there? Is that just y? Yeah, x squared over 10, but is that just y? Okay, now pay close attention. What's that dimension? Y also. Can you see? It's perfectly symmetric. Let's go with this again. Is that Y? Is that Y? So what's the total dimension? 2Y. 2Y. Not Y squared. It's 2Y. That's a Y and another Y. It's the whole distance 2Y. That's how easy that was. They want you to be aware of that. Feel free to write that down on your notebook, please. That's Y and that's Y. Therefore, the total dimension is 2Y. Yeah, that's the new concept, but most kids are not aware of how it works. Oh, by the way, when I open that up, what does that become? 2 squared will become, can I pull it out? So it will become 4, integral 1 to 4 y squared dx. But what was y? So what will that become then? What will it become then? X to the power of over 100. Now, technically, I hope the sharp kids understand, I can totally do this by hand. Can I pull out the 100? Can I integrate that, plug it in? But it is a calculator problem. Okay. But I want to go over how that concept of total dimension works. Can you look at it and think about what just happened? Not a new concept, just the fact that they had one function on top and the same function on the bottom. That height is y, the bottom height is also y. So the total dimension is 2y. Plug it in, we get to go. Alright? This is easy, we're not wasting time. Okay, we will do this. Copy down the table, everybody copy down the table, and also write down this piece of information, which is relevant for the problem. Yes. And I'm giving you advance notice, especially for those of you aiming for a 4 and a 5. Like, I worked too hard in this class, I must get a minimum of 4 or a 5. This problem also comes in slightly different ways. Let's talk about it. I hope you've copied on the table. Okay. By the way, if that is true, what's going on in the graph? The function is louder? No, it says f dash is increasing. Concave up. So this question has also appeared as f is concave up. So you should make the connection, write this down, you should make the connection. If f is concave up, don't get me wrong, we've been doing it last couple of days, then the slopes are increasing. The slopes are increasing. So they have asked the same question using different language. They're saying the function is concave up over that interval. They're saying, okay, then the slopes must be increasing. Everybody okay there? Now the key thing was this, the slopes are increasing. That's the key thing. Now read the question with me. Read the question with me. It says both f and f dash are strictly increasing. Which of the following could be f dash at 3? Which could be f dash at 3? What do we usually do? If all I gave you is this table, I said f dash at 3. Take a guess. What would you do? You just find, not a trick question. Say that loudly, somebody's whispering. MSEC. But what's this? Can we find that MSEC here? Okay, take out your calculators. If you need one, you don't need to take your scientific calculator. I'm okay if you just ask for this guy. If you need a quick calculator, raise your hand. I'll pass out a scientific calculator. Anybody else needs a quick calculator? Here. Pass it to her. Pass it to her. Here. Anybody else needs a quick calculator? I'm okay with a simple scientific calculator. Ms. Robles, catch carefully. Okay, anybody else? Okay, let's move on. Can you please, as Mr. Fong and Ms. Sanders smartly said, just find MSEC. So, grab your calculator. For those of you who are not paying attention, are these the y values and those are the x values? Find MSEC. Quick. Remember, M tan is MSEC. The slope of the tangent line is MSEC. Do it carefully. Don't make mistakes. Find MSEC. Actually do it. Don't wait for others to do it. You need to make a discovery. Boss, you should be working. I need you to be working. Don't rely on others to do the work. Those of you finished, what was the slope? 29 even? Is that the only slope I can calculate? Could I calculate that slope? Find it. And you'll make a discovery. For the kids unable to do, or you're lost, I don't know what to do. y2 minus y1, x2 minus x1. y2 minus y1, x2 minus x1. Okay, those of you ahead, what is the slope? 30.5?
Yeah.
Okay, now if you're clever, look at the choices and choose wisely. Look at everything that we have written down. Repeat. Look at everything we have written down and choose wisely. And the answer is louder. D. You're correct. Tell the class why the answer is D.
Well, those are two possible estimations of this. Do you want to go that full?
Okay, but better explanation. No. You just need to be alive. Look at the board. Ms. Trejo.
Is it strictly increasing?
Well, what are increasing?
The slope?
The slopes are increasing. The slopes need to be increasing. Be alive. These are slopes. You cannot choose 30. Sorry, you cannot choose 30.5. Then they won't be increasing. You cannot choose 29 because then they won't be increasing. So can you please make a note? The answer was, I strongly recommend you copy down the choices so you understand what just happened. Because the slopes are increasing. Go on. Okay, therefore 29 will not work and 30 won't work. 5 will not work. The slopes need to be increasing. Smart girl, right? But that's not a unacceptable explanation. Like, my slope kind of needs to be in between. Especially if they're increasing, right? Okay, I hope you understood how to do the problem. So in general, you're kind of sketching and seeing, hey, okay, let's move on. All right, another question. There's nothing to write. Just write on 82. Okay, I'll be sending you this document. So if you want to look over it before you do the test, go for it. All right. And I'm saying this again. Guys, I have trouble teaching this idea. As in, who's going to imagine a graph where this is not true? Or who's going to say, yeah, I'm just going to leave that alone. I can't visualize what's going on. Okay, put your pencils down. So it says f of x is continuous over the interval ab. That's all that is given. It's only continuous. So look at me. I'm showing you how to think. Could this function work? Will that work? Yeah, it's continuous. Will this work? Watch. I'm showing you to be imaginative. Will this work? Yeah. They're saying who can conceive of different kinds of graphs. Okay, now let's have a look. If you understood my lecture, this should be easy now. There is a number c in that interval such that f of c equals 0. So my question to you is that always going to be true? Because the question says must be true. True or false? False. F of c equals 0 means you have an x-intercept. Can the graph not just be above the axis? Or all of it below the axis? You have to be imaginative. I really can't teach this unless I'm willing to think about it. Okay, have a look at B, please. If you paid attention to my lecture, is B going to be true always? There is a number C such that f of C is bigger than f of A and f of B is bigger than f of C. Think of counter examples. No. If I do the graph this way, that will not always be true. Anybody? Make a graph in the air. That's not true. Anyone? Okay, very smart. Mr. Ton makes a downward going graph. It says f of C should be bigger than f of A and f of B should be bigger than f of C. He says why not going downwards? Thank you. Miss Sanchez draws a graph like that, flat. Does not work. And in the other class, anybody else wants to draw a different graph? In the other class, kids drew a graph. How about a parabola? You're falling then rising. That need not be true. Again, you have to be very sharp on what's going on. So you have an option. I'm going to think, I'm willing to think, or nah, this is just gobbledygook for me. Okay, let's do E. I'm going to work backwards now. E. Must that be always true? What does that remind you of, by the way? M sec equals M tan. And the question to the class is, must that always be true? Does MVTU always apply? Okay, Ms. Trejo correctly nods, saying no. Why? Very smart. Ton, it only said continuous. It need not be differential. You can have a sharp or it is not going to apply. So E is out. Okay, I'll tell you the answer. Come up with a reason. Why is D false also? D need not be true. Why? Give me examples of graphs where that's not true. No, silly, you gave me a reason it's true. Yeah, you gave, Miss Ferguson did this. Aren't you actually supporting the argument? You have to say that's not true. Give me another reason. Ms. Ledesma? Louder? Exactly, if you're rising. F dash doesn't have to be 0. So the correct answer is C. Nobody speaks What is C really talking about in simple language? It says there's a number C such that f of C is always greater or equal to f of x. What's a simple way to say what they're saying? Yes.
C exists on the graph.
No. They say f of C is greater or equal to f of x for any x in the interval. We have discussed this idea before. They're really talking about the absolute maximum. There is a C such that C, f of C, the y value at C is always bigger or equal to. Think of any graph that will satisfy. What's this? Is it f of C greater or equal to any other value? Flat. Greater or equal to. How about this guy? Yeah, f of C is greater or equal to any other x value. How about this guy? Yeah, f of C is greater or equal to any other x value. Draw V. Okay, those guys are greater or equal to any other x value. So, can you please write that sentence in your notebook so I can translate it for you? So that is saying basically there is a value C. There is a value C at which f has an absolute maximum in simple language. But long time ago, day 126, because I have a good memory, 127, 128, 129 classroom notes, we did a theorem called the extreme value theorem. The extreme value theorem says, I'm formally doing a good job. So I'm stating the theorem again. It says if f is continuous over a to b, it must have a maximum. It must have a maximum value. It must have a minimum value. Now, some of you will say, Rama, that's not necessarily true. Watch. What's the maximum value of that function? 5. What's the minimum value of the function? Yeah, it is true. It is always true. So it's called the extreme value theorem. I can draw any kind of graph. That will always. So if it is continuous, there are no breaks. Well, it must have a maximum. It must have a minimum. That's what C was really talking about. Okay, let's move on. But once again, I'm making this emphatically clear. It's really testing kind of your imagination and intelligence. Can you come up with a counter example to the statement? Okay, don't just blindly guess. You're leaving easy points on the table. Okay, this is a gimme. This is points of inflection. Okay, we'll do this. Can you please sketch that figure roughly? Just sketch that figure roughly. Stay with me, don't fall behind. We did this last week on Wednesday, Thursday. Okay? Just have a good memory. This is 0 to 1. They give you a graph like that. Okay. Thank you, Michelle. Okay, now I'm going to scroll down so you can see what the question is talking about. It says a left Riemann sum, a right Riemann sum, and a trapezoidal Riemann sum are used with that graph. It says which will give you an underestimate. A left sum, a right sum, or trapezoidal. So what do we always do with these kind of questions? Draw it. Do that yourselves. So draw a left Riemann sum. What would your rectangle or figure look like? Don't get weirded out. It will be weird. Okay, left Riemann sum is weird. If you understand your concepts. It is okay. Don't freak out. So draw a left Riemann sum. So these are your rectangles. Okay, they're just giving you 0 to 1. So with that, I know I'm letting your left Riemann sum is weird. It's okay. How many of you realize it's kind of weird? Yeah? If your concepts are clear. And then right Riemann sum, draw a rectangle, and then draw a trapezoidal Riemann sum. Okay, then see if you can answer the question. The question says which of them will be underestimates. Those of you finished? The two answers are left Riemann sum and trapezoidal Riemann sum. For the kids struggling with the left Riemann sum, observe the board please. Here's how a left Riemann sum looks like from 0 to 1. I start at the left and go to the right. So it's really 0. Okay, that's your left Riemann sum. Repeat. Darken that and label. That's left Riemann sum. The right Riemann sum is this. Go left. That's right Riemann sum. And this is the trapezoidal Riemann sum. Can you see left and trapezoidal underestimates? Okay. I want to be a good teacher. So I'm also going to sketch. We've done this a couple of times. I want to make sure everybody understands it. If they said midpoint Riemann sum, this is what a midpoint Riemann sum looks like. I'm speaking to the board. Go to the halfway mark and then go to the graph. And then draw your rectangle. I would, just by eyeballing it, I probably Would it be an underestimate or overestimate? We're including that area, and we're saying, isn't this kind of bigger than that guy? Probably. Maybe an over. Okay. I'm just sharing that idea with you. Let's move on.
Will they ask that?
Okay. Read 79, please. Read it with me. Read 79, please. As you read, write something down. Repeat. As you read, write something down. Be smart processors of information. For those of you who say, man, the time limit is always closed, Ms. Morrison. As you read, write something down. What am I writing on my sheet of paper? A of 0 equals 81.637 gallons of water. Now pay close attention. For the next 6 minutes, water flows out of the tank at the rate of 9 sine radical t plus 1 gallons per minute. So what am I writing? L of t equals 9 sine radical t plus 1. Do you understand why we wrote L? Is that a leaving function? Okay. Now the question is very easy. It says, how many gallons of water in the tank are at the end of 6 minutes? So what is my left hand? Not a trick question. Not a trick question. What am I writing on the left hand side? A of 6 equals A of 0. Stop. Stop. Now keep in mind, this is the leaving function. I'm going to teach well. So what should I write there? Minus, because you're only leaving. But I'm going to do a better job. Look at me. I'm doing a better job. Assume I write plus. Interval 0 to 6. Okay, I'm doing a better job. What's the entering function? Be smart. Read the question again if you need to. What's the entering function? What's the entering function? 0 minus L of t. Entering 0, leaving L. Now do you understand why Ms. Sanchez said minus? The minus will come outside. So you understand why we're doing it, rather than just memorizing it. Relax, it's a calculator problem. You just type using your calculator. A of 0 is going to be 81. Let's move on. I just want to show you how to set it up. Okay, read 78, please. You don't need to write. Okay, you don't need to write anything. I was actually alarmed in the other class. The kids were saying random interpretations. Let me read this carefully, please. For t greater or equal to h0 hours, h is a differentiable function of t that gives the temperature in degrees Celsius at an Arctic weather station. Which of the following is the best interpretation of h dash of 24? Is that clear? Now I'm just showing you. We spent a lot of time reading and kids were making like horrifying mistakes. Assume for a second we were interpreting by hand. H dash of 24. Write me a sentence, please. I don't even know what that value is. I don't even care what that value is. H dash of 24 indicates the, again, do not read the choice. See if you can write an interpretation. I don't expect you to finish. I just want you to start the interpretation. This is what I would write. Again, do not read the choices. I'm just saying, will your class outperform the other class? So H dash of 24 indicates that. How do we begin? At t equals 24 hours. The hint, it's H dash. Make up any phrase. Go on. I will accept any phrase. What might you write?
Put the change in temperature.
So you no what? I'm correcting you. Do you interpret the derivative as just the change in temperature? Is that how we interpret derivatives? I'm letting you know you're making a mistake. How do we interpret derivatives? It is the rate of change of temperature. The word rate must be there. It's not the change. Okay, the rate. Okay, now read all the choices and which choice comes closest to what we are talking about. Nobody speaks. Read all the choices carefully. The language is very confusing. But you need to do what we always do. You even change something slightly, a different choice, you would choose something else. Because if you said change, can you see you're choosing A and B? A and B are not the right answer. And the answer is E. Because T was in hours, the 24th hour. read the last stem of E. It says the rate at which temperature is changing at the 24th hour. The speed is 24. Okay, because that's kind of there's a unit issue. Because they're talking about the age of 24. Remember, we use 24 in the interpretation? That's what we are. Okay, don't write yet. Don't write anything yet. I'm just checking a certain skill. Remember, we will copy this down. Watch. I'm going to ask a question. See if you can interpret what I'm trying to get at. Are we good to go when we copy? Why? What do I mean by are we good to go? What am I looking at? Louder? Louder? Thank you. She says, is this lower than that, so we're good to go? What if it was 0 there and 3 here? Should we switch it? You need to know your skills. Are we good to go here? Are we good to go there? Yeah, we are. Okay, copy that down, please. Okay, I want to see if learning happened. We have done like 500 billion problems like this. Write me a right-hand side. Okay, ignore this. What might you do on the right-hand side? Like, okay, that is equal to. I'm checking a very basic skill. If you cannot write me a right-hand side, you don't know how to use this information. This information is useless. We have done a lot of problems. It is not a trick question. Ms. Calderon, what might you write on the right-hand side? This equals what? No, that's not relevant. That's not relevant yet. What will you? You have to calculate that, or you have to calculate this. But what does that equal to? If you cannot reinterpret the problem, you're going to leave points on the table. Mr. Plata?
Like the answer?
No, just the right-hand side. If you see that, I don't want the final answer. There's a lot of work to be done. But if you saw that, what might you work on?
Integral 0 to 0.
Ms. Robles? Guys, pay attention. Robles, you have a soft voice. You have to raise your voice a little bit. Okay, integral 0 to 5. Very good. I love you, Robles. Okay, it is a tragedy that math's loss is art's gain. Since Ms. Robles is an art major, the mathematical field or the sciences are losing a promising candidate. Because once she understands the concept, she does not let it go. That's what you do first. If you are not aware of that, you don't know how to do the concept. You split it up, factor the two. Now it's stupidly easy. Can we integrate 3? That's easily doable. Now what's that? I need the integral from 0 to 5 of f of x. Look there, look there, look at there. What operation should I do to get that value? In simple language, should we add those numbers, subtract those numbers? What are we doing? Add. We know area from 0 to 3. We also know the area from 3 to 5. And we need 0 to 5. So this guy will be the addition of those two. Can we integrate this on the side and add them up? All right? So that's a skill that we've done at least 5-6 problems. At least. But you don't know the first step and you're lost. Okay, stupid problem. Let's move on. Okay, we're coming to the non-calculator part. Okay, that's easy. No, don't write on. We just talk about formulas. Ignore this. What's the formula for the derivative of sine inverse monkey? Nobody speaks. I want you to just process in your mind. Sine inverse monkey. Mr. Jin.
It's positive 5 over rad 1 minus monkey squared.
Okay, alright, I didn't want that, but he's answering the question. That's fine. So it's 1 over radical 1 minus monkey squared times the derivative. He's doing times 5, okay? Chain rule. Oh, by the way, what would you do if it said cos inverse? It's negative, okay? Negative outside the formula is exactly the same. Tan is 1 over 1 plus monkey squared, alright? Okay, we're not writing Sanchez, we're not writing. The question says find f dash of 2. What should we find first? F dash of x, thank you. What concept is involved? Nobody speaks. What concept is involved? Ms. Mendela. I need f dash of x. What concept is involved?
I forgot what to call it. Basically, plugging it.
Thank you. Is that FTC too? So what's this piece? There's no integration involved. You're going to plug in 2x everywhere, take its derivative minus 0. Yes, minus 0. And we're done. It's an easy. Then plug in the 2. Plug in the 2. Oh, this is a weird problem. All right. Can you please copy down F dash and F double dash? You have a problem like this for but I'm letting you know that. But I'm teaching a certain strategy. Okay, after copying that problem, put your pencils down. I want to talk about this kind of problem in general. We have done this kind of problem in general. Now, the question says, I'm speaking to the board, it talks about choices decreasing, increasing. Usually, we make a number line. I want to see if you're conceptually sharp. Why can I not make a number line for that kind of problem? That's ln. We can make number lines only for polynomial functions. We've gone over this. You can't do number lines. So which is the only way to solve that problem? Who remembers? The second derivative test. That's what they didn't say. We have to use the second derivative test for that problem. In general, we find the critical point. We set the top equal to 0, bottom equal to 0, find the critical point, evaluate the second derivative. Okay, in general, I'm saying that's how these problems work. This problem is slightly easier because they're actually giving you choices. How that works. Okay, so what's the board, please? Here's how easily I'm going to do the problem. I'm speaking to the load. If a function is decreasing, it doesn't matter. If a function is decreasing, what must be true? Should be less than 0. Everybody okay there? They actually give us a value to use. I'm going to cleverly use that value to see if it's increasing or decreasing. What's this? I'm going to indirectly make a number line. But observe how I cannot make regular number lines. But there's nothing preventing me from figuring out test values. Play along. Okay. So this is f dash, which is ln x over x. I'm going to make a number line. They say at x greater than 1. Okay, can you see all of them have x greater than 1? So I'm going to use 1. I'm going to take a test value. Okay, I cannot make simple number lines. I cannot do simple number lines. But there's nothing preventing me from using the value they gave me. Smart kids, choose a clever value greater than 1 or smaller than 1 that I can easily plug in there. If you're clever. What value should I plug in? Louder? Very smart. Is E a smart value to choose? Actually, is any variation of E a smart value to choose? Because I know its value. Okay? So, isn't E on the right side? Clearly. So I'm going to plug in E. Let's do this mentally now. What's ln of E? 1. And what's 1 over E? A positive number or a negative number? A positive number. Okay? Therefore, that is going to be a negative number. So is A and B true or false? A and B go together. True or false? True or false? False. Because it says to the right of 1 you're decreasing, but we're actually increasing. So we can eliminate A and B. I'm showing you the strategy. So A and B are out. Did everybody understand the strategy I'm using? Next, can you see C, D, and E are together? So this time cleverly, we've kind of done this. I'm going to deal with the concavity guy. Is that clear? I'll do the second derivative. So f double dash is given to be 1 minus ln x. I'm going to use the same strategy. It's an extremely powerful strategy. What's the value they've given us? No, read the question. E. Okay. I'm going to use a test value method. Smart kids, give me a value bigger than E or less than E that I can very easily plug in. Just be smart. Louder. E squared. I love you. He's thinking any variation of E will work. Isn't E squared clearly on the right side? Okay. What's ln of E squared going to be? 2. What's 1 minus 2? Negative. That's a negative answer. Alright? Oh, by the way, now some of you may say, Rama, I'm not learning this very well. There's nothing preventing you from choosing a value to the left of E. That's E is 2.7. What's a nice value to the left of E? What's an easy value I can plug in? 1. What's ln of 1? 0. 1 minus 0. This is positive. It's very robust. It's very robust. Okay, now which is the correct choice? Look at the choices. Which is the correct answer? The answer is C. It's concave down to the right of E. Is that clear? I hope you understood this general strategy. This is easy. We don't want to waste time on that. Okay, 24 please. My I would be happy if you can translate that using notation. Like a basic skill. It's a related rates problem. Like, can you read that sentence and write something down on your piece of paper? 24. Putting related rates. I'll speak slowly, start writing something down. Do not read it 5 times. The radius of a circle is increasing. At a certain instant, the rate of increase in the area of the circle is numerically equal to twice the rate of increase in its circumference. Write something down. It's a gimme problem. You can get easy the whole points. Okay, Mr. Romero, what did you write? Louder? Okay, I thought you said dV over dt. I'm like, where is V coming from? Equals. Thank you. It's a gimme. It's a gimme. Okay, what do we always need without which I can't solve related rate problems? Relationship. Just staring at the question. What is the obvious 2 relationships that are likely to be involved? Area, which is pi r square. They will not give you formulas. You have crossed middle school, and then circumference is 2 pi r. And once I have relationships, what do? Take the derivative. So what's dA over dt going to be? Related rates. 2 pi. Very good, Ms. Sanchez. And then is 2 pi dr over dt. Okay, look at all the information we have. So what do we do with the information we just found? Not a trick question. What do we do with this information? I set them equal. Thank you. Plug it in over there. This guy will go here. This guy will go here. And the answer will magically show up. The answer will magically show up. If you have a little bit of imagination, you can solve that equation quickly. That's a basic skill. That's a basic skill. We didn't have time to do this. This is an easy problem. Work the choices, please. Okay. Okay, look at that problem. We don't have time to do it. We'll talk about it though. So they give you the f dash graph and they give you area. They give you area. Is that clear? That's 20, that area is 6, that area is 4. And they say f of 0 equals 2. Alright? They say f of 0 equals 2. And the question says, what is the maximum value of f of x? We just finished doing a problem like that. So what should I focus on? Endpoints and critical points. We want absolute maximum. So which guy should I focus on? Calderon, I'm speaking, damn it. Which guy should I focus on? Monkey or donkey? Monkey. Now here's the reason this was tricky. Did they actually label that value? Did they label that value? So what should I do? Thank you. She sweetly says, make up numbers. Like that old strategy. Or, yeah, like seriously, why not? So we're going to evaluate f of 0, f of 10, and then f of monkey. And the answer will show up. Is that clear? You already have the areas. You have the areas. And you know f of 0 is 2. Is that clear? Net change curve. And the answer will show up. Or, I like what she said. Just make up numbers. That guy's 10. Can we call this guy 7 and maybe 9? Doesn't matter. We just need that labeling. Okay? It does not matter what you call it. Okay, let's move on. Okay, copy this down, please. I'm going to rush. I'm kind of running out of time. Okay, write down everything and write me a right-hand side. So basic skill. It's not even a trick question. Write me a right-hand side. If you can correctly write a right-hand side, you know you're fine. You're fine. Look at the information given. What will you write on the next step? She says, oh, I get it. Okay, Miss Huit, what will you write on the right-hand side? Louder? No, that's f of x dx.
Yeah. And then the right hand side would be I put G.
You're correct. She went ahead. She has such strong concepts. She just went ahead and did this. Because f of x is given to be g dash of x. Be alive. Just be alive. G dash of x. And I'm amazed with her. She said, I just went and put g of 3 minus g of 1. Can you see that? Net change. Net change kicks in. Can you see? No integration required. Like I have skills. No integration, no derivatives required. Like I'm alive. I know what's going on. I know what's going on. Okay, easy. We don't have time to do that. We'll talk. We don't have time to do this, guys. How do we? No calculator. How do we always do area problems? I need to find the. How do I find the point of the intersection? Sesame equal. And then what do I write for the integral? What do I write here inside the integral? F of x minus g of x. Doesn't matter which way we write it. We're good. It doesn't matter. It doesn't matter. The answer will show up. Okay. It was an easy problem. Okay. We have time to do only 2 more problems. Okay. One of the hardest problems on this test. Copy that down, please. Okay. And the question said in your notebook, just say f of x graph question mark. The question said which of the following could be the original graph of f of x. And this is a heavy concept problem. So, guys, pay attention. This is the derivative function. The question says, which of those graphs derivative will be that guy? Is that clear? Why is A not the right answer? That's f of x, and they're confusing you as if this is f of x. So that's not how it works. Give me another reason why this can't be f of x. I'll help you focus on some part of the graph. Why could that guy not be f of x? If it is decreasing, the slope must be negative, and the slopes. That was a trick to the question. You recognizing if the derivative is always positive, it's an absolute value function. Make a note. So in other words, always positive because of the absolute value. They wanted you to make that connection. If the slopes are always positive, guys, if the slopes are always positive, the function should be increasing. So which choices can we rule out now? The function should always be increasing. Which choices can we rule out? A, B, and C. Okay, next. The only choice that were relevant were D and E. So which is the correct answer? Stop. D is increasing and so is E. Which is the correct answer? Don't be in a rush. Both are increasing. So which is the correct answer? Anyone? E. Because what? Isn't the breakpoint at 2? Look there. What's the slope at 2? Doesn't exist. But does the slope exist? Yeah. Slope. No, we're going to do one more last problem because I want to match it with the other class. And then we'll be fine with the other class. We'll be exactly with the other class. These are all easy. We didn't get time to do that one. Last problem is that guy. Last one, number 4. Okay, we began the school year with doing 100 of these problems. It says f of x equals cos cube 4x. Question just says find its derivative. Do not look at the choices, they look very, very convincing. Find the derivative all by yourselves. Look down. Look down. Do it carefully. Do not look at the choices, they all kind of look alike. Okay, Mr. Plata. Tell me what you're writing.
3 cos 4x 3.
Like that?
Times sine 4x.
What's the derivative of cos, man?
Negative sine.
Yeah, your formulas are all. Negative sine 4x times 4. You came very close. Okay. Power rule, then chain rule. Is that clear? Power rule, then chain rule. Wouldn't I want to talk to you for 20 seconds? You're not in trouble. Guys, make sure you turn in yesterday's assignment. Jacob.
It's too late.
I'm here. Do not forget, I'll see you.
Yeah, bro.
Yeah. Well, the bowling comes at 7:35. Come on. Yeah, thank you.
Wait, do you have like charge though?
Yeah, no. What's going on? Today is in off. Huh?
Thank you. Oh my gosh, I'm so sorry.
Oh, Alex. No guns allowed.
No matter how you feel.